Can we survive on Mars? For now, though, all eyes are on Mars, a mere 180-day journey away and a possible target for a future human colony. And this isn't merely science fiction, the space race has already begun. How do we get to Mars? The furthest we have sent astronauts is to the Moon, about 240,000 miles away. This is small fry compared to the 35 million-mile journey to Mars. Reaching the red planet will require some serious hardware. NASA will use its new heavy-lift rocket, the Space Launch System, SLS, to propel Orion, the new generation of spacecraft, into space. The SLS is more powerful than any previous rocket, firing over 8.4 million pounds of thrust, equal to 135 Boeing 747s. The computers running the software on Orion have the ability to handle 480 million instructions per second. There's been speculation that astronauts will be put into hypersleep, a therapeutic coma, during the journey to Mars and kept alive intravenously, to conserve resources. Although a favorite trope of sci-fi films, experts think this unlikely. How will we live? Humans will need self-sustaining water, food and oxygen to survive on Mars. Extracting water locked up in ice will be crucial, but with the recent discovery of flowing water on Mars may not be too difficult. NASA is developing an excavator device called RASER, Regolith Advanced Surface Systems Operations Robot, designed to mine water, ice and fuel from planetary soil. Mars One also plans to send a water extractor to heat the soil until the water evaporates. The water will then be condensed and stored, the dry soil expelled and the process repeated. Mars One claims its astronauts will have 50 liters of recyclable water every day. Food will need to be grown and harvested, but farming in space isn't easy. You can't plunk crops into Earth and sprinkle on water, because in microgravity-free soil and water will fly around and foul the interior of the spacecraft. Plants can be grown in space, but all require the management of gases, water and a growing substrate. The crop is perfect for Mars, able to grow on a 10 cm petri dish and closely related to vegetables such as broccoli and radish. It matures quickly and scientists already know its complete genetic code. Special growing systems will be required, such as Veggie, the Vegetable Production System Project, a microwave-sized chamber in which plants receive carbon dioxide and controlled-release fertilizer, and fans stir the air. NASA is working with Systems and Material Research Corporation, SMRC, to develop a 3D printer to mold protein, starch and fat into shapes and microjet in flavors and nutrients. We're not trying for out-of-this-world designs, Irvin says. The food shape will be practical to guarantee even cooking and efficient processing times. We're not planning for Michelin star food, just healthy and nutritious meals. At Mars One, meanwhile, it's been suggested that the colonists might recycle human waste to provide nutrients for their crops, and their diet might include insects and algae. Plants might be used to produce oxygen as well. Dr. Paul claims a bank of photosynthetic organisms, such as green algae, could be used for this task. NASA also plans to convert the carbon dioxide that dominates the thin Martian air into oxygen using MOXIE, a machine able to produce 3/4 of an ounce of oxygen an hour. If successful, a bigger device will launch 2 years before astronauts land on Mars, to produce oxygen for human respiration and for rocket fuel. Physical and psychological impacts. Space travel comes with a health warning. Using the International Space Station, ISS, as a test bed, element scientist Professor Peter Norsk of NASA's Human Research Program has been investigating some of the physical challenges that astronauts will face. Our bodies work differently in space, even the way our blood flows. On Earth, gravity drags bodily fluids downwards, but in space this doesn't happen, so the heart has to work harder to pump out more blood and more fluids accumulate in the head, putting extra pressure on the eyes. Russian cosmonauts place their bodies in low-pressure boxes to draw blood into the legs and wear bracelets around their thighs and upper arms so blood accumulates in the veins of the limbs. NASA is currently testing the effectiveness of this. Astronauts on ISS do 2 hours of daily aerobic, resistance and treadmill exercises to stave off the effects of weightlessness, which causes rapid bone and muscle wastage. Professor Norsk says the same countermeasure will be used on Mars, which has roughly 1/3 of the gravity of Earth. The use of the osteoporosis drug bisphosphonate to prevent bone mass loss is another option, and artificial gravity is being tested using a centrifuge spinning device. Diet will also be important, and scientists are looking at foods that protect bone health and are rich in antioxidants to boost immunity. Space plays havoc with the immune system. Blood plasma samples taken from astronauts before and after a voyage show that some cells fail to kick in when needed, awakening latent viruses such as chickenpox, while others are overactive and cause allergy symptoms. As well as physical challenges, the isolation, confinement and loss of privacy associated with long-duration space travel can provoke mental health problems such as depression. In March, American astronaut Scott Kelly and Russian cosmonaut Mikhail Kornienko will set off for a one-year mission on ISS, during which a host of psychological tests will take place to see how they cope mentally. NASA is also trailing a virtual space station, using a virtual reality headset to send calming sounds, smells and images, and provide access to a virtual therapist and a self-administered depression treatment program. The technical trials of reaching and inhabiting Mars are immense, but perhaps the greatest challenge is the threat posed by radiation. Astronauts who travel beyond low Earth orbit are outside the protective shield of Earth's atmosphere and magnetic field, exposing them to galactic cosmic rays that damage DNA and increase cancer risk. NASA prohibits its astronauts from increasing their probability of dying from cancer by more than 3%, but at least one expert has estimated that exposure to radiation on Mars could cut 15 to 24 years off an astronaut's life. NASA admits there's insufficient knowledge of the health effects of radiation, the space radiation environment and countermeasure efficacy, to recommend crew exposure limits for extended lunar and Mars missions. The plan so far is to shield space vehicles and habitats to protect the humans inside. Orion has radiation sensors, and will use the mass already on board to maximize the amount of material, including equipment, supplies, launch and re-entry seats, that can be placed between the crew and the outside environment. The Mars One living quarters will be covered with 16 feet of soil, to shield the inhabitants from cosmic rays. Their scientists say this will provide the same protection as the Earth's atmosphere. Differences between Earth and Mars. There are some similarities between Earth and Mars, such as the fact that they both rotate around the Sun and have a similar axis tilt. The Earth's atmosphere is composed of nitrogen and oxygen. Mars, on the other hand, is carbon dioxide based. While both planets have ice caps, the ice contains different elements. On Earth, ice contains just water. On Mars, ice is a mixture of water and carbon dioxide. Mars' surface is rock and dust, while Earth's surface is 70% water. Two satellites orbit Mars, namely, Phobos and Deimos. The Moon is the only satellite to orbit the Earth. There are some climates on Earth that experience extreme temperature shifts between seasons. However, that does not compare to what humans would encounter on Mars. It can get to -220 degrees in winter, while in summer, it can be a pleasant +70. The time it takes Mars to orbit the Sun is longer than it is for Earth. However, a day on Mars is about the same amount of time as it is on Earth. Asterisk: how long is a day on Mars? One thing that attracts scientists to the idea of humans living on Mars is that it has a similar axis tilt and orbits the Sun. However, the orbit is longer than that of Earth. So exactly how long is a day on Mars? Well, because Mars is further from the Sun, it takes the planet 687 days to orbit it. Compared to the 365 days for Earth, that makes a Mars year much longer. Even with this time discrepancy, the length of a Mars day is similar to Earth. A full day's rotation on its axis takes 24 hours and 37 minutes or, about 40 minutes longer. Another similarity between Earth and Mars is the presence of seasons on the red planet. However, the temperature is much more extreme due to the thin atmosphere and proximity to the Sun. Aside from the necessities to sustain life, there are other challenges that people would face if they were to live on Mars. For example, the temperature gets very, very cold at night, below -100 degrees Fahrenheit. Mars also has dust storms, high levels of radiation, and less gravity than Earth. So, before we can start to call the red planet home, we'll need to solve these problems.